Alright, so this video will be introducing complex valued functions, and basically for complex valued functions it's really just very similar to real functions, except that of course now we just have f of z rather than f of x, for example. And that's equal to some omega, and of course these are all complex numbers. So in complex analysis, the functions that we're going to be looking at are going to be a little bit weird. And by weird I mean that they're not what you'd expect to get as a result. Like when you try to map functions in real numbers, it kind of makes sense. But in complex numbers, there are a lot of subtleties in the functions. And these subtleties can make the graph look different than what you expected. And of course, once you study it more, you'll understand what I mean. But basically, let's just say we have, before I even get into functions, it's important to go over, review some terminology. So basically, if let's suppose this circle out here, the outer circle right here, that's the entire domain. So, for example, like if you have 1 over x, the domain is all real numbers except for 0, of course. And then of course, this smaller circle in here that I shaded in, that is the pre-image, and that is essentially just a subset of the domain. It's really just any subset of the domain. And then this, of course, you map this to the image, which is just the range. So this is, of course, all possible y values. If, of course, you have a function like y equals f of x, these are all the possible y values, and of course this small circle I shaded in here, that's the image. And the range is just a set of all images. And pretty much it's important to get this terminology down because when we graph functions, this will be just completely, this is a fundamental concept when graphing functions basically. It's just important to get the terminology down. And so I wrote f of z here, maps to the range. And of course if you want to go backwards, which would be like finding the inverse, you go from range to the domain. And that's kind of just like what you'd expect, because it's exactly the same as real valued functions. And sometimes you see, actually, when I write f inverse of z, it's not too common to see that. There are other ways to write that, but basically, it really means the exact same thing. It means what you'd expect it to mean, just the inverse of f of z. So the next video I'll be talking about actual concrete examples when I'm actually going to show some functions you can map. I'll start with something simple, and then we'll get into some more complicated mappings. But basically, I'm not going to get anything too complicated because I will not be able to draw it, but I'm just going to kind of show you the idea of what's going on. So that's all for this video, and I'll see you guys in the next one.